Welcome to The Explainer. You ever wonder how Netflix just knows what to recommend? Instantly, across every single one of your devices? Well, today, we're going to pull back the curtain on the incredible graph technology that makes it all happen. It's a system managing a world of data so massive, the numbers are absolutely staggering. So what's the big question here? For most of us, Netflix is just a library of movies and shows. But behind that play button, there's this colossal invisible web of data connecting everything. And it's changing at a speed that's just hard to wrap your head around. We're talking nearly 10 million times every single second. How on earth do they pull that off? To get it, you've got to understand that there are basically two ways databases work. You've got OLEP, which is for deep, slow analysis. Finding those hidden insights in huge piles of data. But Netflix, oh no. They live in the fast lane. They are all about OLTP, which is pure live action. It's all about speed, spitting out results in milliseconds. Because when you hit play, performance is everything.
Okay, let's really dive into this. What is this graph we're talking about anyway? And why is it such an insane challenge to manage in real time?
So forget spreadsheets. The best way to picture this is like a giant social network, but for everything. It's the web that connects your account to your profile, and your profile to that TV in the living room. It connects your gaming handle to your friends list. It even connects Netflix's own internal computers to each other. This graph is literally the brain behind the entire operation, powering your recommendations all the way to their internal troubleshooting. So when you're staring down a challenge this big, where do you even start? Do you build something totally new from scratch? Well, the engineers at Netflix had a much cleverer idea. And here it is, their core philosophy. Don't reinvent the wheel. Instead, they decided to build taller. See, they already had these incredibly powerful, battle-tested systems, like their databases and their caching layers. So instead of digging a whole new foundation, they just built a skyscraper on top of the one they already had. It's a brilliant engineering move that saves a ton of time and cuts out a ton of risk. So how did they actually build it? All right, let's top the hood and take a look inside the engine room. There are three really smart design choices that make this whole thing possible. First up is the graph schema. You can think of this as the constitution, the master blueprint for their entire data universe. It's a super strict rulebook that says this is what a user is, this is what a device is, and here are the only ways they're allowed to connect. It's the foundation that keeps the whole thing from turning into chaos. And having a rulebook like that, it pays off big time. It means the data stays incredibly clean because anything that doesn't follow the rules just gets rejected. It also lets the system plan the smartest, fastest route to find information, kind of like a GPS avoiding traffic. It stops the system from running in circles, and most importantly, it gets rid of dead ends before a search even starts. It's all about efficiency. All right, the second key idea has a bit of a fancy name, idempotency, but the concept is actually really simple. It just guarantees that doing the same thing twice or 10 times has the exact same result as doing it just once. Now, in a huge global system where network connections fail all the time, this is an absolutely critical safety feature. It means the system can safely retry a failed update without ever worrying about, say, adding the same movie to your list 5 times. And this third choice, man, this might be the most clever trick of them all. So here's the problem. A single user can have millions of connections in this graph. The slow way to handle that is to store all the connections and all the details about them in one giant clunky record. That's a guaranteed traffic jam for your database. But the Netflix way is genius. They separate the links, the connections themselves, from the properties, all the heavy details about those connections. The result? The system can grab a list of connections at lightning speed because it doesn't have to carry all that extra weight. This right here is a huge key to their performance. Okay, the last piece of this speed puzzle is smart caching. The system is always fighting against two big problems. One is write amplification, where your one little click forces the database to make a whole bunch of updates. The other is read amplification, where one simple search forces the system to dig through thousands of records. Caching is the hero that solves both. It works like a short-term memory or a cheat sheet, keeping the most common data ready to go. This takes a massive load off the main database and makes everything feel totally instant. But what happens when things go wrong? We're talking about a system running in data centers all around the globe. Keeping all that data perfectly in sync is a massive challenge. So to solve this, Netflix makes a really deliberate trade-off. They use something called eventual consistency. It basically means they accept that for a tiny, tiny fraction of a second, the data in one part of the world might be slightly different from another. And in exchange for that tiny moment of being out of sync, they get incredible speed and availability. The system's guarantee is right there in the name. If things quiet down, all the data will eventually match up perfectly.
And, of course, they have a safety net for that model, so when a write fails, it doesn't just disappear. No way. The failed operation gets sent to a special log. Then, an automated system comes along, picks up that failed message, and just keeps trying to write it again and again until it finally succeeds. They have a cool name for it, entropy repair, and it's their guarantee that data never gets permanently lost just because of some temporary network glitch.
So, after all of this brilliant, incredibly clever engineering, what's the bottom line? What does the performance actually look like? Well, the numbers are just, frankly, astounding. So here's the payoff. During peak hours, this system handles a staggering 10 million operations. Reads, writes, lookups, you name it. Every single second. Let that sink in. 10 million. And it's managing all of this across a massive 650 terabytes of data spread all across the entire globe. But for my money, this is the most impressive number of all, the latency, the actual speed you feel. A typical data lookup takes just 3 milliseconds for most people, and even for the slowest 1% of requests, it's still only 8 milliseconds. For perspective, it takes you about 100 milliseconds to blink. The system is literally more than 10 times faster than a blink of an eye. And as this quote from their own tech blog shows, this isn't just about today. This whole system is the foundation for Netflix's future. As they push into live content, into games, and ads, this graph is what will let them connect all those new things together and make it all feel like a seamless experience for you. Which kind of brings us to a final thought. This invisible graph technology, this web of connections, it isn't unique to Netflix. As our entire digital world gets more and more connected, it really makes you wonder, doesn't it? What other hidden networks are out there, running right now, powering the apps that you use on your phone every single day?